In this video, I want to calculate the voltage gain of this circuit with the following parameters given. So first of all, what do we even have here? We have two transistors, one NPN and one PNP transistor. With this transistor, we have the input voltage at the base and the output voltage is at the collector. The emitter is connected to the ground, so we basically have an emitter circuit here. With this transistor, the input voltage is also connected to the base, but this time the output voltage is applied to the emitter, because this is a PNP transistor and the collector this time is at the bottom here, connected to ground, means that this is a collector circuit. So first of all, how do we calculate the voltage gain of the first emitter circuit? From the input voltage to the output voltage 1. Well, for the voltage gain of an emitter circuit, we have the formula that is minus the transconductance of the transistor times the load resistor. Okay. So, but what is the load resistor in this case? Well, it's the resistor 1 in parallel to the input resistance of the transistor 2 in parallel to the output resistance of the transistor 1. So let's first calculate the resistor 1. If we assume for the operating point that the collector emitter voltage is half of the supply voltage, then we can go a loop from the supply voltage over the resistor 1, over the transistor 1, back to ground. And we will basically get this equation. But what is the current over the resistor 1? Well, at this node we can see that the current splits into the base current of the transistor 2 and into the collector current of the transistor 1. So the current over the resistor 1 is collector current 1 plus the base current 2. The collector currents of both transistors are already given. As we know, the base current is just the collector current divided by the current gain. So we get this equation for the current over the resistor 1, and all these parameters are given, so we can put it into the calculator. So we get 99 microamperes. If we now solve this for the resistor 1, we get that the resistor 1 is the supply voltage minus the collector emitter voltage, which is just half of the supply voltage, divided by our current over the resistor 1. If we further simplify this equation, we basically just get this formula. So with all the parameters given, we get that the resistor 1 is 60.6 kilo ohms. Alright, so now let's look at the output resistance of the transistor 1. As we know, this is an emitter circuit, and with an emitter circuit, the output resistance is just the collector emitter resistance. This is a basic formula for the collector emitter resistance, and with all these parameters given, we get the resistor is 156 kilo ohms. The only thing in this equation that's left, that we don't know yet, is the input resistance of the second transistor in the collector circuit. The input resistance of a collector circuit is defined as the following equation. The load resistor here is basically just the resistor 2 in parallel to the resistor 3. And as we know, the base emitter resistance is just the terminal voltage times the current gain divided by the collector current. To simplify this a little bit, we'll assume that the collector emitter resistance of the second transistor is the same as the collector emitter resistance of the first transistor, with 156 kilo ohms. And with that given, all of these components are given, and we can put it into the calculator. And we'll get an input resistance of around 12.59 kilo ohms. So now that we've calculated the three resistors, we can finally calculate the voltage gain from the input voltage to the first output voltage. As a reminder, the transconductance is just the collector current divided by the terminal voltage. So the final result for the voltage gain is minus 375.82. Now let's head on to the second transistor circuit from the output voltage 1 to the output voltage 2. And the formula for the voltage gain of a collector circuit looks something like this. And if we plug this into the calculator, we get something around 0.9999992. So this is the voltage gain of the second collector circuit. If we now finally want to calculate the voltage gain of the whole circuit from the first input voltage to the output voltage, all we have to do is to multiply the two part voltage gains, because as we can see, the voltage in between just cancels out and we have the output voltage of the whole circuit and the input voltage. And yeah, if we multiply these two, we just get 375.8.82.